Alright, welcome back. Again, things are a little bit different today just because I don't have a pen to use, so I'm planning on typing into a document. We are continuing through all the rest of the free response questions as we go through March. And then at the end, Oliver is also asked to look at some of the mock exam questions, so I'll take any questions from that. So goal for today is to determine the displacement, distance traveled, velocity, speed, acceleration, magnitude of acceleration of a moving particle. We've kind of gone over the displacement, velocity, acceleration, jerk relationship a couple times already. So I'm just going to dive in, and that way we'll have more time for questions at the end. Okay, so this is 2001 number 2. So this would have been with a calculator, I believe. We have temperature in degrees Celsius of water in a pond, which is given as this differentiable function of W in terms of time. The table above shows the water temperature is recorded every 3 days over a 15-day period. So days, degrees Celsius. First thing I want to do is use the data to get an estimate for W prime at 12, and then show how we got to our answer and indicate the units of measure. Okay, so how can I figure out the derivative of W at 12 if we don't have a function of W, if we just have this tabular data? Yeah, you can drop and rejoin. You can drop and rejoin. There's also a document both on WeChat and Skype, so if it freezes, you can download that and catch up. Okay. So what can we do to find W prime at 12? Do you know any ideas? Okay, again, we don't have a function. We've just got this tabular data. So how can I get a derivative from a bunch of points? Approximate? Okay. So how would you get your approximation? Use a slope. Okay. So what would our formula be if we wanted to get our slope at 12? Okay. Which points would you use if you wanted to get an estimate for 12? Okay, so we can use 9, and we could use the point on the other side. So I'm going to take my slope between 9 and 15, and that should give us an estimate for what the slope would be at 12. Okay, so that would look like this. W prime at 12 is roughly equal to W at 15 minus W at 9 over 15 minus 9. So W at 15 is 21, W at 9 is 24. So this is 21 minus 24 on top. And then on bottom is 15 minus 9. Okay, so that's negative 3 over 6. Or negative 1/2. What would our units be? Celsius per day, perfect. Okay, when you're showing your work, make sure you show your general form, so you do need this step here, W15 minus W9 over 15 minus 9. If they're asking you to show your computations, then you can't just skip into where you're plugging your numbers in. They need to know where you're plugging your or where your numbers came from. Okay, then I want to estimate the average temperature in degrees Celsius of the water over the time interval from 0 to 15 using a trapezoidal approximation with subintervals of length dt equals 3. Okay, so they're asking for a trapezoidal Riemann sum. So what that means is we've got these different heights. At 0, 3, 6, 9, 12, and 15. And we're going to use them to create a bunch of trapezoids. So something like this. How could I get the area of this first trapezoid? Okay, you're right, keep going. Okay, so you've got 1/2, and you give me your base, which was 3. So that's 1/2 times your base, times... Okay, so the area of a trapezoid is your average of your heights times your base. So what are my two heights? 20 and 31. Okay, so my general form would look like this. H1 plus H2. That's the average of my heights, H1 plus H2 divided by 2 times your base. Okay, so I'm going to do that for each of these. Ah. Okay. So we could say... okay, I want average temperature. So if I get a trapezoidal Riemann sum, that'll be area underneath the curve. That'll be the sum total of all temperatures at all times, right? So how could I get from my trapezoidal Riemann sum to the average temperature? Divide by 15, perfect. Okay, so my average temperature, let's see, I want to accent this. There we go. Average temperature is equal to 1 divided by 15 times our trapezoidal Riemann sum, which, Oliver, you gave me the first one, would be 3 times 1/2 times 3 times 21, or sorry, 20 plus 31 is... Okay, Junho, what would my next trapezoid be? Okay, 3 times so this first part is my base. So this is 3 units for the first one we did. 3 units, and then we had heights of 20 and 31. So my trapezoid for the first one was 1/2 of 3 times 20 plus 31. Okay, what about my second trapezoid? Okay, 3 times 1/2 times, say one more time. Okay, 31 and 28. Okay, so that's another 1/2. 3 and 31 plus 28. Okay, and I'm just going to keep doing that for all of these. Plus 1/2 of 3 times 28 plus 24. Plus 1/2 3 times 24 plus 22. Plus 1/2 of 3 times 22 plus 21. Okay. So you'll notice I've got a 1/2 and 3 in all of this. So I'm just going to factor that out. So that'll leave me with this. W prime equals 1 times 15 times 1/2 times 3 times all of the numbers that I had on the inside when I add them up. So this is 20 plus 31 is 51. Plus 31 plus 28 is 59. Plus 28 plus 24 is 62. Plus 24 plus 22 is 46. Plus 22 plus 21 is 43. Okay, any questions so far? Okay, so the 3 and the 15 can cancel, so that's 1/5 times 1/2 is 1/10. So I've got W prime is now 1/10 of what happens when I sum all of this up. So I'm going to throw the 1 over here, so that's 60 plus 50 is 110. 172. 178 plus 4 is 218. 221 to 61 I've got. Okay, double check myself because it's kind of early. So 51 plus 59 plus 62 plus 46 plus 43 is 261. Okay. And then when we divide by 10, that's 26.1. Okay. They didn't ask for units, but what would my units be for this? This is my average W. Celsius. So okay. Then we have a student that proposes a new function p, which is given by p of t is equal to 20 plus 10t times e to the negative t over 3. as a model for the temperature of the water in the pond at time t, where t is measured in days and pt is measured in degrees Celsius. I want to find the derivative at 12, and then explain the meaning of the answer using appropriate units in terms of water temperature. Okay, so the first thing they want us to do is to derive p and find the derivative at 12. So let me copy p really quick. We were given that p of t is equal to 20 plus 10t e to the negative t over 3. Okay. I think we're back to Oliver. So what's going to happen when I derive this? Okay, 10 times e to the negative t over 3. Okay. Plus close. This is chain rule. So I need the derivative of the inside part. If you derive e to the x, you get e to the x dx, right? What's the okay, our rule is if you derive e raised to the x, you get e to the x times dx, right? So my power is negative t over 3. What would the derivative be? Okay, 1 over 3. So this was product rule first. So we had two functions that were multiplying together. So I derived the 10t to get 10, and then the second part will stay the same. Plus the first part stays the same, and then the derivative of the second. So this derivative is just e to the negative t over 3. And when you derive that negative t over 3, you get negative 1/3. Okay, now I do have stuff that I could potentially factor out of this. I'm wondering if I should. Is it going to help us when we plug in 12? I mean, I guess so. So sure. I'm going to factor this out, and we'll simplify. So what I'm going to do is I'm going to pull out this e to the negative t over 3. And then what I'll be left with on the inside is 10 minus 10/3 times t. Okay, any questions on what I did there? Okay, I'm going to write this as another line maybe. So we'll put that down here. P prime at any t value we want is equal to this. Okay, and then we were asked to solve this at 12. myself some space really quick. Okay, so if I plug in 12, what's going to happen?
P, the derivative P of 12 is equal to e raised to negative 12 over 3 times 10 minus 10 over 3 times.
Okay, times 10 minus 10 over 3 times 12. What's 10 thirds times 12?
10 over 3 times 12.
Right, what is 10 over 3 times 12?
40.
40. Okay, so this should be negative 30 e to the negative fourth power. Okay, what are my units for the derivative of p?
The change in temperature of the water over time.
Okay, and then time is measured in what?
Time is measured in days.
Days. And temperature is measured in Celsius. This would be change in. Okay. So this would be degrees Celsius per day.
Degrees over Celsius.
Celsius per day. Didn't work like I thought it would. There we go. Degrees Celsius per day. Okay. And then they asked us to explain, I think. Explain the meaning of your answer in terms of water temperature. So the temperature of the water is decreasing at a rate of 30 e to the negative fourth degrees Celsius per day. When? So if we're explaining the meaning, we got negative 30 e to the negative fourth degrees Celsius per day for p prime at 12. So what does this mean? When though? So when is this true?
What was the question?
I want to explain what this means. Okay, so on day number 12, the temperature is decreasing at a rate of 30 e to the negative fourth degrees Celsius per day. Okay, so because this is with a calculator, I could probably get a decimal for that. 30 e to the negative fourth, 0.54946. I think I'm going to leave it like this just so we're exact, but I could say the temperature of the water is decreasing at a rate of 0.549 degrees Celsius per day on day 12. Something like that. Okay. Try that. Then I'll get this on one page. Okay. Last one. I'm going to use the function we just got for p to find the average value of p on the interval from 0 to 15 days. So what could I do to get the average value?
Divide by 15.
Okay. So if I just divide by 15, that'll give me average slope, right? So I need to do a little bit more.
Integrate.
Right. So I'm going to integrate pt from 0 to 15, and then I'll divide by 15. So that'll step up, and then step me back down to get an average. So we could say something like this. The average value for p, if you ever see this bar over a variable, that just means average. So my average value for p is equal to 1 over 15 times the integral from 0 to 15 of pt dt. Okay, we can do that really quick. Again, since this is with a calculator, we can just plug this in. So this is 1 over 15 times the integral of 20 plus 10t times e to the negative t over 3 in terms of t from 0 to 15. Is 25.757. Okay, what are my units for this? Degrees Celsius, okay. So this is my average value of p. So this would be degrees Celsius. Okay, cool. So let's see how we did. Scoring guides. Okay, so for the first one, they had us trying to find a difference quotient where we're using two of the points. Okay, so we used this one, and that was negative 1/2 degrees Celsius per day. Okay, negative 1/2 degrees Celsius per day and a difference quotient. Looks good. Okay, so difference quotient, 1 point, answer with units. 1 point. Okay, difference quotient, answer with units. Looks good. So I'm going to give us 2. Then okay, for the second one, we've got a trapezoidal method and answer of 25.1 degrees Celsius. Oops, I'm off by 1. Okay, they've pulled out the 3 halves. We did that too. Okay, 20 used once, 31 used twice, 28 used twice. That was good. 24 used twice, and then 22 used twice, 21 used once. 22 used twice, 21 used once. That's all fine. Then average would be 1/15 of that. Okay, I don't see anything different with her math. Did I add wrong? 20 plus 31 is 51. 31 plus 28 is 59. 28 plus 24 is 62. 24. 46. 43. Okay. don't see it. 28, 24. It's 261, that's the same thing we got. Alright, we don't match, I don't see what's wrong, so here we go again. So 51. Oop. Down here. 20 plus 31, so I've got 51 plus 31 plus 28. 59 plus 28 plus 24. 52. 46 and 43. 251. Okay, so I added wrong somewhere. 51, 59, 62. 28 plus 24 is 52. Okay, that's where we went wrong. That decreases by 10 for our final answer. This would be 251 instead. And 251 divided by 10 is 25.1. Okay, so we would get only 1 point there, because we did use trapezoidal method correctly, but we didn't use the answer. Okay, this way that they've done trapezoidal method is with grouping. So they pulled out the 3 halves, kind of like what we did here. But then every one of these additions, I'm adding the sides that we use twice 2 times. And I'm adding the sides that we use the ends only once. So you can see we only have 120, but we have 2 31s. Okay, so kind of a shortcut on their part. It ends up being the same math. Okay, then we've got our p prime at 12, which is negative 30 e to the negative 4th. In our interpretation, the temperature is decreasing at that rate when t is 12 days. Okay, that's good. So we've got 2 points there. And then our average value, 1/12 of pt, is 25.757. Okay, so integrand, everything on the inside. Okay, we did do pt dt. Limits an average value constant, 0 to 15 and 115 in our answer. Okay, that was good. So that's 3. Okay, so we would have made 8 out of 9 for that. Because I didn't add correctly for that one answer. Any questions on this one?
No.
Okay. So let me save that, and then I'll jump into the mock exam that we had last time to open for any questions. Okay. Oliver, did you have any questions that you wanted to ask?
Yes. Wait, let's see. The last question, for example.
Okay. Okay, so this last one, we had an X-ray scanner passing through some sort of spherical egg that was measuring the area of this circular cross-section formed by the laser. So it looks something like this. So here in blue is my laser, and here in red is the cross-section that we're scanning right now with the X-ray. The area of each circular cross-section is given as a function of the height of the cross-section for the lower hemisphere of the egg, where the height is between 5 centimeters and 0 centimeters from the base of the sphere. So this is, my height is from the bottom, and we're continuously getting cross-sections between 0 centimeters and 5 centimeters for height. Our area is 20 pi h minus pi h squared for any one of those heights. At the time when the height is 2 centimeters and decreasing at a rate of 1/4 centimeters per minute, I want to know how fast the area of the cross section is decreasing. Okay, so I'm going to start with what was given. I've got my area equation. If I derive it, I'll get a prime. So with chain rule, my only variable here is really height. So when I derive 20 pi h, I'll get 20 pi h prime. And when I derive negative pi h squared, I'll get negative 2 pi h prime. Okay, then we were told how fast the area is, how fast this laser was decreasing. We're decreasing at a rate of 1/4 centimeters per minute, and we know what the height is right now, 2 centimeters, so we can plug in directly. H prime is negative 1/4, and h is 2. Okay, so that gives us negative 1/4 times 20 pi is negative 5 pi, and then negative 4 pi times negative 1/4 is pi. So that gives us negative 4 pi centimeters squared per minute. Okay, now they asked how fast, which is a speed. Speed does not have direction, so this negative won't show up in our answer. If they asked us for the velocity would have direction and the negative would matter. Okay, any other questions from this one? If you want time to look at it first, I can take questions at the end of our next class as well too, if you want. Okay, so I've posted in the chat, I wrote all of my steps for how I solved these in the explanations. Again, these are all problems that I've taken a look at previous AP exams and then kind of recreated new problems that were based on the old ones. And I tried to look at their wrong answers and try to make my wrong answers similar to how they made their wrong answers. So it's kind of my best guess. But that's because since we can't come to campus with the coronavirus, I can't give you any of the practice tests from College Board that are secure as long as we're online. Okay, so there may be a mistake or two in here. If you find something that looks really weird, again, because these are all my problems, let me know and I can take another look. Okay, well, thank you guys very much for coming. Oh.
How did you score the test?
How did I grade the test? So there's 27 questions, so first I got a grade out of 27. But because that's not how your grade would be weighted on the AP exam, your weight ended up being, I did whatever your score was out of 27 times 50 plus 50 should be your score. That's not really how College Board would weight, but it's reasonable if you got half of these right for you to get a 3. So I would expect that to be in a C range if you got half of these. So it works out just about right. All right, any other questions on anything? Okay, so I'm going to post homework in the chat. I want us to go through a couple more of these free response questions. So we just did one today. I'm going to do the rest of the with calculator ones. So that's question number 1 and question number 3. And that's going to be it for today. And I will post that to both of our chats right now. So here for Skype.
About the last homework?
Okay.
Because I always have the troubles with the
Let's see. FRQ from 2000.
yes. The number 6. I don't understand how to do differential equations.
Okay, so our first step is the most important. First step, we need to separate our variables. So I'm going to throw all my y's to one side and all of my x's to the other. I guess let me do this. Through this keyboard. I did this the keyboard. 1,000, 2,000, 3,000, 4,000, 5,000. There we go. Okay. Okay, so for part A, I'm going to start with our differential equation here. So that would look something like this. Dy over dx is equal to 3x squared over e to the 2y. And then I was also told f at 0 is 1/2. Okay, my goal is to find what y would be. So my first step is going to be to separate these variables. So I'm going to throw all my y's to one side. E to the 2y is equal to 3x squared dx. dy. Okay, so I've got all of my y's on one side and all of my x's on the other. That allows me to integrate directly. So if I integrate both sides, I'll have something that looks like this. What happens when I integrate the left side? Okay, so when I derive, I would multiply by 2. So when I integrate, what's going to happen?
Raise by 1 and divide by the number.
Okay, I heard from Junho I'm going to divide by 2, so we're just going to do the opposite of whatever we would do when we derive. So if I derive and multiply by 2, then I'm going to integrate and divide by 2. Okay, I would have a plus c, but I'm going to throw that to the other side, equals. My next one would be, oh, Oliver's telling me what's going to happen on the right. Okay, so I'm going to raise this power by 1 and then divide by the neighbor power. So this is going to be 3x cubed over 3, or just x cubed, plus c. Okay. And then from here, I think I'm going to solve for c at this point. So I was told that f at 0 is 1/2. So to solve for c, I could say e to the 2 times my y value of 1/2 divided by 2 should be equal to our input, which was 0, plus c. And we can solve for c. Okay, so then 2 times 1/2 is 1, so this is e over 2 is c. And if that's true, I can go back to this step and plug in for c. So we know c now is e over 2. Okay, so now my goal is to solve for y. So I'm going to first multiply everything by 2. And then to get rid of this base e, I'm going to take the natural log of both sides. So that'll be 2y is equal to the natural log of everything that was on this side, 2x cubed plus e. And unfortunately, I can't simplify that with my properties of logarithms because I'm not multiplying here. So I have to keep this like this. And then I'll divide by 2 to get our y value. ln of 2x cubed plus c over 2. Okay, so that's a solution satisfying f of 0 is 1/2. And I can check when I plug in x equals 0. I'll get ln e, which is 1, divided by 2 is 1/2. Any questions on our first part? Okay, for the second part, they asked for the domain and range of our new function. So I'm just looking for domain and range of this question. Okay, domain is all x values that you can plug in. So is there anything that would make an x value not okay to plug into this function? Can I take a natural log of a negative number? No. Can I take a natural log of 0? Okay. So then the part that's inside the natural log, 2x cubed plus e, must be greater than 0. And we can solve that to figure out what our domain has to be. So if that's true, then 2x cubed must be greater than negative e. I just subtracted e from both sides. I'm going to divide by 2 on both sides. So x cubed must be greater than negative e over 2. And then cube root both sides. So x must be greater than the cubed root of negative e over 2. Okay, now because this is an odd power root, it is okay to keep this negative. So that's my domain. X must be bigger than the cubed root of negative e over 2 in order for this function to be possible. My range tells me what y values are possible. I'll write on this domain what x values are possible for fx. Range is what y values are possible for fx. Okay. So for my range for this, my smallest possible y value is going to be what happens if I take my limit as x approaches this value but is larger than it. And then my largest possible value, natural log keeps increasing forever, so it'll actually be infinity. So I could say, thanks, you too. Y will be greater than what happens when I plug in the limit as x approaches this value from the right. So that would be the natural, I'll do limit as, I need to do this over here, I think. Limit, here. Okay, the limit has x approaches the cubed root of negative e over 2 from the right of the natural log of 2x cubed plus e over 2. And we know our function goes to infinity if I keep going larger and larger for x, so it'll keep going larger than that. So if I do this, my natural log will approach 0, but not get to 0, right? My natural log approaches negative infinity as I approach 0. So this is negative infinity, really. So my y is between negative infinity and positive infinity. Or we could say our range is all real numbers. Are possible for y. Okay, any questions on anything from this one? Okay, I'm going to post my work for this one and the other one we did in the chat, and then I'll also post the scoring guides. And I think that'll be it for today. Okay, anything else you guys need before? Okay, if you guys have other questions, let me know and we can cover them after class next time. Or if they're fast, you can throw them in WeChat and I'll answer them there.
Okay.
Homework number 6. Okay. Thank you. We'll catch you later.
Okay, bye.
Goodbye.